Hey, welcome back folks. Thanks for joining us as we take a look at how we set up and sail with our servo-pendulum self-steering system. For a comprehensive video of the various systems, follow the link in the description below. So, what makes the system so useful as opposed to electric autopilots? Most importantly, autopilot systems use power, and some of them a lot of power. This is fine during the day when your batteries have been recharged by solar, but what happens overnight? It could be a major drain on your power supply. So, we've hoisted and trimmed our sails according to our course of sail in relation to the wind. We are ready to go from hand steering or autopilot to self-steering using the wind. Our first and most important step before we engage our self-steering is to ensure our sails are balanced. By balancing the sails, we can eliminate excessive weather helm where the vessel luffs up into the wind, caused by excessive heeling. The opposite effect of this is a lee helm, where the boat tends to bear away from the wind. With balanced sails, we should have a relatively balanced helm. To check out our sail trim video, follow the link in the description below. So to start, we deploy the system and drop the trim blade into the water. The vane itself is made of a light material that can withstand the harsh environment of ocean sailing. This vane can swing from side to side, depending on where the wind hits it. The bottom of the swivel houses a lead weight which returns the vane to its upright position when not affected by the apparent wind. We want to keep the vane in this upright position. To do this, we have a rotating drum that can be adjusted by hand or with the line running into the cockpit. And this will be our next step, to rotate the vane so that it faces directly into the apparent wind. When facing the wind, it stays upright. If not, it will be blown over away from the wind. When facing the apparent wind, the wind passes the vane in equal measures on either side. As long as the boat stays on course and there are no drastic changes in the wind direction or strength, the vane stays upright and does not attempt to alter our steering. If the boat veers off this course, or if we have a change in apparent wind, the vane gets blown over, depending on where the wind hits it from. By means of mechanics, this causes our blade to rotate. This, however, is not what turns the boat. When the blade faces into the water stream, it stays centered. As it rotates, the water movement will either push it out to port or to starboard, depending on the movement of the vane above. This pendulum is made up of two parts, the bottom blade in the water and then the top part, which is out of the water. If the blade pushes to port, the top part will move to starboard, and if the blade pushes to starboard, the top section moves to port. Onto this top section of the pendulum, we have our control lines. One line moves from the pendulum to the starboard blocks, and then of course we have another line running from the pendulum through to the port side. These control lines are joined by a length of chain which can hook into the control clip which is mounted on the tiller and therefore controls the tiller's movement. If the chain is not hooked up to the control clip, the system has no effect on steering. The system first gets set up correctly and then we clip it on to control the tiller. Now, a quick recap, then we'll have a look at an example and then chat about how to offset the system to counter weather helm. But first, the success of our channel depends on engagement, so please hit us with a like, subscribe and turn on notifications. A comment will be great and much appreciated. For those who wish to contribute more, our Patreon and PayPal links are in the channel header. The vane is affected by the wind and can be blown over from side to side, causing the blade to rotate. Water forces the blade up to port or starboard and the pendulum pulls and pushes the control lines. These lines move the chain which is clipped to the tiller, causing changes to steering in our tiller and therefore rudder. Now let's go through a quick example. Our sails are trimmed and balanced and we have rotated the vane to face the apparent wind. Our vessel veers off slightly and bears away to port. This causes the wind to hit the vane on its starboard side and get blown over. This causes the blade to rotate anti-clockwise, and the water movement pushes the blade out to the port side. This in turn moves the top part of the pendulum over to starboard. Now the pendulum will be pulling on the port control line and pushing on the starboard control line. This pulls the tiller to lee, which causes a turn to starboard. As we turn to starboard, the wind again hits the vane equally on both sides, and it will return to its upright position, which in turn sets the blade back to center, which then moves our tiller back to center, and we are back on course. At times we will have to offset the system to account for weather or lee helm. In stronger winds, our boat tends to heel, causing it to luff up into the wind. This is known as weather helm, where the boat continuously wants to turn to wind. To counter this, we might have to offset the chain link that we are using. Usually we use the middle link, which is marked accordingly. With weather helm, we can change the link used so that our tiller is offset to counter this action. It might take a few tries, but eventually you could get there. Self-steering systems steer in relation to the apparent wind. Due to slight changes in wind strength and direction, you can expect your track to look a little something like this, as opposed to an autopilot which steers to a compass bearing and tracks a straight line. Because of this, self-steering is better suited for long ocean passages and not ideal for use in coastal sailing, where we experience many changes in our apparent wind. And that's how we do it. Let us know in the comments below if you have any suggestions or remarks. We'd love to hear from you. Fair wind sailors, and see you soon.